Heidi ho, neighborinos. I don't know if you remember this, but a couple videos ago, a couple dozen videos ago, I started a video from the same watt-hour meter on the back of my house, and if you look at the direction it was spinning, the little quiet dog, the little black dot right there was going left to right, and now it's going right to left. I have set my inverter to export, I don't know, 3, 4, 5 amps, just to keep it low for now. We don't want to be too generous until we figure out what the equilibrium of our system is. That's what I tried to show you in the previous episode. This is our AC power. We have power going to our inverter, power coming from our inverter, and then that goes through the wall to our AC fuse box. Okay, I think you guys have all seen this a few times. We still have yet to finish the installation of all the stuff. We have fan, power, wires, and battery temperature sensors to wire to the batteries. We're going to do that this afternoon. But look at this. This top light says inverting. Flashing equals sell. We're selling to the grid and we're powering my home. Our battery voltage is hovering between 52.5 and 52.8 roughly. My load is roughly 600 watts. AC1 is about 1,000 watts. I think what that means is I'm selling a kilowatt to the grid, basically banking that, storing it, if you will, with extreme efficiency. In other words, if I charge batteries and then discharge batteries, I may get 85% efficiency possibly. When I go through that meter, I don't get any charge and discharge efficiencies that I lose with my batteries. However, I still have my batteries charged. As you can see, it's a little off of full. It's like a fuel gauge here. And this represents my load as a percentage of full load. So as you can see, I have quite a ways to go before I reach full load. I was going to wait a while before I went into grid cell, but in effort to figure out how to get this thing inverting this morning, I turned it on, only to realize that it's kind of hard to get this thing with this configuration to go into grid cell with separate battery chargers until they are networked together. Once we got a working network cable in place, it just kind of started working. This, again, I think I mentioned this in my last video, this control panel is going to mount there. There's only so much you can do in a 24-hour day. Let's show you underneath here. I don't think I've shown you that yet. We've got a pair of 1/0 multi-stranded cables with a pair of ferrite beads. This is our 48-volt input to the inverter. This is our ZAN bus connection. It's not Ethernet, although it looks identical and wires identical to Ethernet. It is not Ethernet, and the manual says you can damage your system if you plug this into Ethernet. The display unit gets its power from the inverter. In other words, if the inverter is not on, if it's not online, even though the chargers may be powered up, your master control panel will not have power. The inverter provides network power supply power for the control panels. So we are fully commissioned. We had a little bit of a glitch this morning when I got up. Tried to figure out why we weren't inverting, why we weren't exporting, and came to realize after a lot of panicking and dumping the house once and resetting all the clocks that they do in fact have to be talking. Not a big surprise, but learning experience nonetheless. So, this is a good day. We are now joining the ranks of the power company and selling kilowatts. So during the day we can produce a ton of power, bank some of it to the batteries and bank some of it to the grid, and we can start spinning that meter the other way when we're ready to. Wow, kind of neat.